what they are. All right. So what's a hyperbola? It's centered at 3, 1. Has foci at 7, 1. And -1, 1. And vertices at 5, 1. And 1, 1. Okay, I just like to draw them out because it helps me to see. I know it's going like this. So it's horizontal. The x's have to be first. We can tell the distance. We can just count it off. A is 2. And then C is 4. And for our equation, we need the center and H and K. H and K for the center. And we need A and B. We know A is 2. And we know 4 squared equals 2 squared plus B squared. So 16 equals 4 plus B squared. So 12 equals B squared. And that's really all we need for the equation is B squared. So we have our equation x minus 3 squared over A squared, which is 2 squared, 4, minus y minus 1 squared over B squared, which is 12, equals 1. And we found the equation of the hyperbola. All right. One of the last things we're going to do is complete the square to finish it out. And we'll complete the square by going through the same steps we did with the ellipse. You're going to group your like terms and put your constant on the other side. It's already there. So we want 4x squared plus 16x minus 9y squared plus 18y equals 29. And then we're going to factor out the leading coefficients. In a minute. So we have 4 on the x squared. Now be careful on the 9 because you're factoring out a -9. So that has to be minus 2y equals 29. All right. And then half the coefficient of x or y squared added to both of these. So we've got half of 4 is 2 squared is 4. And half of 2 is 1 squared is 1. But remember on this side, you're not adding 4 and 1. You're doing the multiple. So 4 times 4 is 16. And -9 times 1 is minus 9 to get a total of 36. Condense. So we have 4 times the quantity x plus 2 squared minus 9 times the quantity y minus 1 squared equals 36. And again, we divide. And we get x plus 2 squared over 9 minus y minus 1 squared over 4 equals 1. And there's our final equation, the way we wanted it. Our last thing is applications. And applications for hyperbolas in space. Elliptical orbits were the planets, but comets are hyperbolic orbits. So sometimes you'll see that. Another one is microphones, estimating where a shot has come from, or an explosion, or some kind of sound. So if we have two microphones that are a mile apart, that's 5,280. So split that and you get 2,640 each. And an explosion happens and it goes to microphone A 2 seconds faster than microphone B. Where would we find the explosion? Well, you have to know that sound travels 1,100 feet per second. So we know that the difference between A and B, how fast it went, was 2,200 feet, because it was 2 seconds and 1,100 feet per second. So that 2,200 is A, or is 2A. So A is 1,100. We don't know B, but we do know C, because C, the microphones are at the foci. So we know C is 2,640. So to get the equation, all we need is B, as we'll center it at 0, 0 to make it easier on ourselves. So 2,640 squared equals 1,100 squared plus B squared. You solve that, and you get B squared equals 5,759,600. And then we just put it in the equation. X squared over 1,100 squared is 1,210,000 minus Y squared over 5,759,600. And we'd say on one branch of that equation. You can't tell exactly unless you have another point of reference to triangulate, but that's enough for what they want us to do, is basically just find the equation. Okay, so there's hyperbolas for you guys. Have fun practicing. Use a straight edge. I know mine weren't very good because I didn't have a straight edge, but it helps when you're drawing your asymptotes. All right.